Hello students, welcome back to the channel. Today we want to learn about 8th standard science. The topic name is light part 2. Already we discussed mirror types, images formed by spherical mirrors and applications of curved mirrors in part 1 video. So in this video we want to learn laws of reflection, types of reflection, refraction of light, refractive index and dispersion. So first we move to reflection. A ray of light falling on a body having a shiny, polished and smooth surface alone is bounced back. This bouncing back of the light rays as they fall on the smooth, shiny and polished surface called reflection. The relation between the incident ray, the reflected ray and the normal is given as the laws of reflection. The laws of reflection are as follows. Number 1, the incident ray, the reflected ray and the normal at the point of incident all lie in the same plane. Number 2, the angle of incident I, the angle of reflection R are always equal. These laws are true for all reflecting surfaces for plane mirrors as well as curved mirrors. So next we move to types of reflection. The amount of reflection of a light depends on the nature of the reflecting surface of the body. Based on the nature of the surface, reflection can be classified into two types, namely number 1, regular reflection and number 2, irregular reflection or diffuse reflection. So first we move to a regular reflection. For example, plane mirror or any other surface that produces a reflected image. Diffuse reflection. This is like any surface that we can see but does not reflect an image. First we move to regular reflection. When a beam of light falls on a smooth surface, it gets reflected. After reflection, the reflected rays will be parallel to each other. The angle of incidence, the angle of reflection of each ray will be equal. Hence, the law of reflection is obeyed in this case and thus a clear image is formed. This reflection is called regular reflection or specular reflection. For example, reflection of a light by a plane mirror and a reflection of a light from the surface of still water. Next we move to irregular reflection. In the case of a body having a rough or irregular surface, each region of the surface is inclined at different angles. When light falls on such a surface, the light rays are reflected at different angles. In this case, the angle of incidence and the angle of reflection of each ray are not equal. Hence, the law of reflection is not obeyed in this case, and thus the image is not clear. Such a reflection is called irregular reflection or diffused reflection. Example, reflection of a light from a wall. Number 3, multiple reflections. For example, take two plane mirrors and keep them perpendicular to each other. Place a nail polish bottle or any other object between them. You can see the images of the object. How many images do you see in the mirror? You can see 7 images. How is it possible to have 7 images with the two mirrors? This is because the image formed by one mirror acts as an object for the other mirror. The image formed by the first mirror acts as an object for the second mirror. Thus we have 7 images of a single body. This is known as multiple reflection. This type of reflections can be seen in showrooms and saloons. The number of images formed depends on the angle of inclination of the mirrors. If the angle between the two mirrors is a factor of 360 degree, then the total number of reflection is finite. If theta is the angle of inclination of the plane mirrors, the number of images formed is equal to 360 degree by theta minus 1. As you decrease this angle, the number of images formed increases. When they are parallel to each other, the number of images formed becomes infinite. Problem: if two plane mirrors are inclined to each other, of images formed is equal to 360 degree divided by theta minus 1. 360 degree divided by 90 degree minus 1 is equal to 4 minus 1 is equal to 3 images. Just see the pictures. If you increase the angle of inclination, the number of images formed is a decrease. Next we move to kaleidoscope. It is a device which functions on the principle of multiple reflection of light. It produces numerous patterns of images. It has two or more mirrors inclined to each other. It can be designed from inexpensive materials. The colorful image patterns formed by this will be pleasing to you. This instrument is used as a toy for children. Next we move to periscope. It is an instrument used for viewing bodies or ships which are over and around another body or a submarine. It is based on the principle of the law of reflection of light. It consists of a long outer case, and inside this case mirrors or prisms are kept at each end, inclined at an angle of 45 degree. Light coming from the distant body falls on the mirror at the top end of the periscope and gets reflected vertically downward. This light is reflected again by the second mirror kept at the bottom, so as travel horizontally and reach the eye of the observer. In some complex periscopes, optic fiber is used instead of mirrors for obtaining a higher resolution. The distance between the mirrors varies depending on the purpose. Next, uses of periscope. It is used in warfare and navigation of the submarine. In military, it is used for pointing and firing guns from a bunker. Number 3. Photographs of important places can be taken through periscopes without trespassing restricted military regions. Number 4. Fiber optic periscopes are used by doctors as endoscopes to view internal organs of the body. We know that when a light ray falls on a polished surface placed in air, it is reflected into the air itself. When it falls on a transparent material, it is not reflected completely, but a part of it is reflected, a part of it is absorbed, and most of the light passes through it. Through air, light travels with a speed of 3 into 10 power 8 meters second power minus 1, but it cannot travel with the same speed in water or glass because optically denser medium such as water and glass offer some resistance to the light rays. So, light rays traveling from a rarer medium like air into a denser medium like glass or water are deviated from their straight line path. This bending of a light above the normal at the point of incidence as it passes from one transparent medium to another is called refraction of light. Take a glass beaker, fill it with water, and place a pencil in it. Now look at the pencil through the beaker. Does it appear straight? No. It will appear to be bent at the surface of the water. Why? So in this activity, the light rays actually travel from the water. Water is a denser medium into the air. Air is a rarer medium. As you saw earlier, when a light ray travels from a denser medium to a rarer medium, it is deviated from its straight line path. So the pencil appears to be bent when you see it through the glass of water. Next we move to refractive index. Refraction of light in a medium depends on the speed of light in that medium. When the speed of light in a medium is more, the bending is less, and when the speed of light is less, the bending is more. The amount of refraction of light in the medium is denoted by a term known as refractive index of the medium, which is the ratio of the speed of light in the air to the speed of light in that particular medium. It is also known as absolute refractive index, and it denoted by Greek letter mu. So mu is equal to speed of light in air c divided by speed of light in the medium v. Refractive index of some materials as shown in table column. Just see that vacuum index of refraction is 1.000, air 1.000277, water 1.333333, ice 1.31, glass about 1.5, diamond 2.417. Next we move to Snell's law of refraction. Refraction of light rays as they travel from one medium to another medium obeys two laws which are known as Snell's law of refraction. They are: number 1, the incident ray, the refracted ray and the normal at the point of intersection all lie in the same plane. Number 2, the ratio of the sine of the angle of incident I to the sine of the angle of refraction R is equal to refractive index of the medium, which is a constant. When a light ray travels in a denser medium, it slows down and bends towards the normal. When it moves into less dense medium, it speeds up and bends away from the normal. So Snell's law tells about n1 sin theta 1 is equal to n2 sin theta 2. n1 divided by n2 is equal to v2 divided by v1. Next we move to dispersion. Splitting of white light into its 7 constituent colors, that is wavelength, on passing through a transparent medium is known as dispersion of light. Splitting of white light into its 7 constituent colors, wavelength, on passing through a transparent medium is known as dispersion of light. For example, place a prism on a table and keep a white screen near it. Now with the help of any light source, allow white light to pass through the prism. What do you see? You can observe that white light splits into 7 colored light rays, namely violet, indigo, blue, green, yellow, orange and red on the screen. Now place another prism in its inverted position between the first prism and the screen. Now what do you observe on the screen? You can observe that white light is coming out of the second prism. For this example, you can see that the first prism splits the white light into 7 colored light rays and the second prism recombines them into white light again. Thus, it is clear that white light consists of 7 colors. So, refraction of a light ray is inversely proportional to its wavelength. For example, the formation of rainbow is an example of dispersion of white light. This can be seen on the opposite side of the sun. After rainfall, large number of droplets still remain suspended in the air. When white light passes through them, it is split into 7 colors. Dispersion of white light from a large number of droplets eventually form a rainbow. If you have any suggestions and doubts,